Hello, my name is Scott Bryson, and I'm an applications engineer supporting position sensing products at Texas Instruments. In this video, I will discuss using the TI Magnetic Sense Simulator to model a tilted axis of rotation using some advanced alignment strategies for multiple sensors. The standard rotation format in the simulation tool rotates a magnet about the z-axis. When left centered at the origin, the magnet will spin about its own center. However, as we discussed in our video that demonstrates strategies for rotation in other directions, we can configure rotation about the x-axis using the hinge function. Here we can create a system that helps us change our frame of reference to match how we might envision rotation in some devices, such as a scroll wheel commonly found in your computer mouse. Suppose we imagine a mouse scroll wheel that is composed of a ceramic magnet coated in rubber and free to rotate above a 3D Hall effect sensor. We can easily model the centered rotation using the hinge function, but a particular challenge occurs if we want to look at the behavior of the scroll wheel when the wheel is tilted left or right. A complex rotation like this, where the magnet spins about an axis which is tilted away from horizontal, cannot be done directly by the TI Magnetic Sense Simulator. Within the TI Magnetic Sense Simulator, when a tilt is applied to the magnet position, this relative alignment is maintained throughout the entire rotation, and the end result that we observe when we try this produces a wobble effect. This models the behavior of the magnet if it were not seated perpendicularly to the rotating axle. Instead, our goal for this simulation is to model the result when the rotating axle itself is tilted. So let's look at how we can model this field from a fixed tilt. Let's imagine the tilt of the magnet about its own center by about 15 degrees. If we rotate our perspective back by the same 15 degrees, the magnet appears to straighten again, but our sensor is now offset and tilted from its original position. If we duplicate our sensor in the TI Magnetic Sense Simulator, we can place our second sensor at this new location so that we can observe the behavior of the magnetic field for both the vertical case and when the scroll wheel is tilted left or right at any position. The challenge is correctly calculating the position we want to use to do this. Imagine a coordinate location shown here at distance d from the origin, which will be our magnet center in this example. We can look at this location as the individual x and y coordinates, or as a vector at some angle, shown here as theta, from the x-axis. In this case, we would represent our starting x and y coordinates using basic trigonometric functions. This represents our starting position, but let's now look at how we could rotate this vector to find new coordinates for our tilted reference. Rotating our vector about the origin will give us a second target location. This rotation is effectively added to our initial angle theta, and we could represent this here by the angle phi. The final coordinates could be calculated using the sum of theta and phi, similar to how we determine the initial coordinates, but in many cases we start only knowing the initial coordinates, and it's possible to determine the final position by combining this information with the trigonometry identity function for the sum of angles. The end result allows us to quickly determine the new location using only our applied tilt and the starting coordinates. If we return to our initial example, we can find the correct location for the sensor by entering our known values into the formula we just explored. Using our known starting position, we can then predict that our sensor will have a final location of x equals negative 0.78 millimeters and z equals negative 14.5 millimeters. Let's try this out now in the TI Magnetic Sense Simulator. We can see here our sensor is placed beneath the magnet at the desired initial starting position. Let's edit the sensor selection and click the plus sign in the tile that shows our selected sensor to increase the count to 2. We can return to the simulation settings, select the second sensor, and enter a value of z equals negative 14.5 millimeters and x equals negative 0.78 millimeters. We now see our sensor in the calculated position, but still aligned orthogonally to the magnet. We also need to add a 90-degree rotation about z to get the sensor aligned to match the initial sensor, and a 15-degree tilt about x to produce the orientation that we need. In this example, there's a large separation between sensors, but the tool will also allow you to overlap the sensor package bodies without any problem. Clicking Simulate, we can see our animated model like before, as well as step to the second sensor to explore how tilt affected our measurements. To sum up, we have learned how to model rotation about a tilted axis by adding multiple sensors to our simulation and using simple transformations to calculate the new final position using our initial coordinates. To learn more about the TI Magnetic Sense Simulator, please visit the tool page and check out the user's guide, as well as many other resources available on TI.com. You can get started on your simulation today at www.ti.com/TIMSS.